Hello and welcome. Ansys Fluent is a general purpose tool for simulating fluid flow. It uses an intuitive UI for fast and efficient problem setup, solution, and post-processing. While Ansys Fluent has built-in capabilities to cover a majority of situations, there may be cases which require special customization. For example, a user may want to impose a spatially varying velocity profile at the inlet boundary, or create a special function that is a combination of the existing functions for the purpose of post-processing. For such cases, the user-defined tab can be used to define the appropriate functions. This tab can be used to customize Ansys Fluent and enhance its capabilities, for example, to impose special boundary conditions, apply custom material properties, employ new physical models, reaction rates, source terms, customize post-processing, solve user-supplied partial differential equations, and much more. The user-defined tab is located on the right side of the Physics tab. Here, we have various options grouped under Field Functions Group, User-Defined Group, and Model-Specific Group. In this course, we will learn about the most commonly used options available under field functions and user-defined groups. Particularly in this lesson, we will learn about the custom field function calculator, units, and parameters options available under the field functions group. So, without further delay, let's get started. Launch Ansys Fluent in solution mode. Once the Ansys Fluent solver launches, load the provided case file. Once the file is loaded, go to User-Defined tab in the ribbon of Ansys Fluent solver. In the User-Defined tab, the first group is Field Functions. The first option in the Field Functions group is Custom Field Function Calculator. Ansys Fluent has many variables that are available to the user by default. However, there can be situations where certain modified versions of these variables or a combination of variables is needed, primarily for post-processing purposes. For this reason, we have Custom Field Functions Calculator. Clicking on it opens the Custom Field Functions Calculator in a new pop-up window. Custom Field Functions is also available in the outline view under Parameters and Customization. You can access it by right-clicking on Custom Field Functions and selecting New. For the purpose of this demo, we will quickly define a field function for calculating the pressure ratio. To define the custom field function, we come here at this dialog box. This dialog box allows the user to define custom field functions or variables based on existing functions using simple calculator operators. The definition displays the function being defined. To give input to definition, various field functions or variables can be selected from the Field Functions drop-down menu. The various subcomponents of field functions or variables can be selected from the second drop-down menu here. For our demo, the pressure ratio is given by this formula. Here in our demo, the operating pressure is 101,325 Pascal and gauge pressure is 0. In order to start defining the pressure ratio, we will select round bracket first. Then, from the field functions, we will select pressure and static pressure. As it can be seen, any field function selected from the list or button pressed on the calculator appears in the definition text box. One thing to note is that we cannot edit the contents of this box directly. If we want to delete part of a function, we can do so by pressing the delete key here in the calculator keypad. Next, we will select addition operator and type 101325 for operating pressure and close the bracket. Next, we will click on division operator followed by round open bracket and then select 0 as gauge pressure is 0 in this example. Next, we will click on addition operator and for operating pressure, we will again select 101325 from calculator button. Finally, we will click on close bracket to complete the formula. Once the custom field function has been defined, we can give it a desired name by typing in the new function name text box. For our demo, we will name it as pressure ratio. Once you click on define, the custom field function is saved. A similar process can be followed to create more new functions. The list of all your custom field functions can be accessed by clicking on Manage. This panel allows us to rename or even delete a field function. If we want to save the definition of our field functions into a file, we can do it by clicking the Save button. We can then load this file in future Ansys Fluent sessions using the Load button, and this will result in the definition of these functions without having to create them from scratch. The next option in the field functions group is units. Ansys Fluent uses SI units by default for all variables while solving any problem. However, there may be instances where user may want to set up their problems using different units for a particular variable. This can be done using the Units menu. Ansys Fluent has 4 built-in unit systems: Default, SI, British, and CGS. Clicking on the Default button applies the default system of units to all the variables. The default system is similar to SI system, the only difference being that it uses degrees instead of radians for angles. To choose the English Engineering Standard, click British button. If we want to use the International System of Units for all variables, we can do so by clicking on SI button. The CGS centimeter gram second standard can be selected by clicking on CGS button. One thing to note is that clicking on any of these options under Set All To applies the selected unit system to all the variables immediately. To change the unit of a specific variable, we need to select that variable from here and then choose the desired unit for that quantity from the available units in this window. Here, the factor and offset of the selected unit with respect to the SI unit is displayed by default for reference. To quickly select the specific variable, click on any variable in this window and type the first letter of required variable on your keyboard. This will take you to the first variable beginning with that letter, after which you can scroll and select the desired variable. Before customizing units for one or more variables, if you want to know the current units chosen by Ansys Fluent, you can click on List button here. This will display a list containing all variables with their current units, conversion factors, and offsets in the console. Suppose that we want to define a new unit for the selected variable which is not one of the available units. For example, say we want to create micrometer unit for length. We can do this by clicking on New button. This opens the Define Unit dialog box. The selected variable appears in the quantity field. Enter the name of the new unit as micrometer in unit field. Provide conversion factor of 0.000001 in the factor field and offset as 0 in the offset field. Click OK to define the new unit. The new unit will appear in Set Units dialog box as can be seen here. After the units, we have parameters. Ansys Fluent lets users perform parametric studies, which involves defining a set of key simulation inputs and results and studying the change in response of the results when one or more inputs is changed over a prescribed range of values. One can perform multiple simulations without having to leave Ansys Fluent, as the parametric study does not involve a change in geometry or mesh. Let's look at a quick demo of how to define the parameters. Here, we have a case in which we will study the influence of inlet velocity on the average temperature at an outlet of the given geometry. If we go to the inlet zone of the boundary condition, the velocity has been defined as a constant value here. We will change this to parameter by clicking on this drop-down list and selecting New Input Parameter. In the parameter expression dialog box, we will name this as inlet velocity. Notice that the Use as Input Parameter is selected by default. Click OK to create the parameter. Once the parameter is defined, its name is displayed next to the velocity magnitude and also in the drop-down list of the property being defined as can be seen here. To complete the setup of the input parameter creation in the inlet boundary condition, click Apply. We have already created report definition for the average outlet temperature. To create it as an output parameter, we will go to Report Definitions, select the outlet temperature report and click on Create Output Parameter. Once the input and output parameters have been created, click on Parameters to open the Parameters dialog box. Parameters can also be accessed from the outline view by expanding the Parameters and Customization option and then double-clicking on Parameters. The Parameters dialog box shows both the input and the output parameters that we have created. Here, we get some buttons using which we can perform certain tasks on parameters like editing, deleting, renaming, etc. Having created the input and the output parameters, we can now go to the Parametric tab to set up and run our parametric study. A discussion regarding setting up the parametric study is beyond the scope of this course. For more information about parametric runs, please refer to the user's guide or our other advanced courses. Let's summarize what we have learned in this lesson. We briefly looked at what the user-defined functions are, their need, and usage. Then we learned about how to create field functions using Custom Field Functions Calculator. Next, we learned in detail about the Units option of the Ansys Fluent software, including how to create own units by making use of the Define Unit dialog box. Finally, we discussed about parameters and how to create input and output parameters for use in the Parametric tab of Ansys Fluent for carrying out the parametric studies. With that, let's wrap up this lesson.